Hello everyone. Today let's solve the problem number 410, split array largest sum. So what the question states here, we are given an array nums. You can clearly see here we have been given array nums and the integer k. You can clearly see here integer k is nothing but the number of splits here. So we have been given an array nums and the integer k. We have to split the nums into k non-empty contiguous subarrays. So this has to be contiguous subarrays. So that's what we need to keep in mind. We have the number of splits that is available for this particular input is 2, and maximum number of splits is 2. And one more thing, this has to be the numbers that we need to consider here as contiguous subarray. We have to consider contiguous subarray. So suppose if we are considering this one 7 and we cannot consider 10 directly, 7 and 10, we have to go with either 7 2 5 10 itself, right? If we are considering 7 2 5, we cannot consider just 7 and 5, we have to consider 7 2 5. So this one thing we have to keep in mind. Given an array nums and an integer k, split the nums into k non-empty contiguous subarrays. This is fine. What is our main goal here? Our main goal is to minimize the largest sum among these subarrays, right? So our main goal is to minimize the largest sum among these subarrays. So what we need to return here? Return this minimized largest possible subarray sum. We have to return the minimized largest possible subarray sum. Again, I'm telling we have to return the minimized largest possible subarray sum, right? So here in this case, you can clearly see. Let's come to the first example. They have given nums here 7, 2, 5, 10, 8 and k equals 2. So the number of splits that is this one that's available for this particular input is 2 and the output is 18. How? Because there are 4 ways to split the nums into two subarrays. The best way is to split, so the number of splits should be 2, right? Here 7 to 5 we can split nothing but here 5 6 7, 7 plus 7 is 14, and this will yield us to the 18, 10 and 10 and 8. So among these two, 18 is the greatest, right? So where the largest sum among the two subarrays is only 18, is only 18, right? So this one, the output is 18 here in this case. Let's come to the second example. So here we have been given 1 2 3 4 5, k equals to, again we have the number of splits is 2 here. So there are 4 ways to split the nums into two subarrays, right? So we have to split this one into the two contiguous subarrays. We can four there are 4 ways basically. So the best way is to split 1 2 3 and 4 5, 1 2 3 and 4 5. This will yield us to this one 6 and 9. So the output will be quite obviously 9. The maximum will be 9 and we have to return the max here. So but the largest sum among the two subarrays is only 9. This is fine. So I hope this part is completely clear. What we need to do is completely clear. Let's discuss the approach followed by the complexities and then let's write the code. For the approach part, let's consider the first example. So let's consider the first example. Now we know what we need to do. What is k basically? What we need to do? What is what we have to do within the nums array, right? So how many number of splits they have given, based on which what we have to consider the this one largest number among the splits. So that we know now. So let's discuss the approach followed by the complexities and then let's start writing the code. So just give me a second here. So here low we have 10 and the high we have 32. Nothing but here low is nothing but the maximum number here. Within this array, maximum number is 10 and 32 is nothing but here the sum of all the numbers. Sum of all the numbers. So we are going with the range 10 to 32. We are going with the range 10 to 32 here. Don't get confused. 10 is nothing but the maximum number within the array and 32 is nothing but the this one sum of all the numbers within this array. So you can just sum up this one. 7 plus 2 9, 9 plus 5 14, 14 plus 10 24, 24 plus 8 is nothing but 32, right? The total sum is 32 here. 10 comma 32, we are going with the range 10 comma 32 here, right? 10 comma 32. So this will be, when we are calculating mid, this would be 10 plus 32 by 2. 10 plus 32 by 2. 32 plus 10 is nothing but 42. 42 by 2 is nothing but here in this case 21. We get 21, right? So this one will be 42 by 2. Yeah, 42 by 2, nothing but here this will be 21. 21, right? So the mid that we got here is 21. So we are so I wanted to tell you one more thing. So before the approach, so here we will be going with a binary search approach for this problem. So I forgot this one. So we'll be going with a binary search approach for this particular problem. So here now we have as we are going with the binary search, the range is from 10 to 32, maximum number within the array, and 32 is the sum of all the numbers, and first we have to calculate the mid, right? Binary search. We are going with a pure binary search here. In this case, 10 plus 32 by 2, here we got 21. 21 as mid. So 21, we will try splitting with the maximum subarray sum less than or equal to 21. So as we got the mid 21, what we'll do, we'll try splitting with the maximum subarray sum, nothing but less than or equal to 21. So here we can split in this way. One is we can consider 7 to 5. The first three numbers we can consider 7, 2 and 5. What it will give here. And another one is this one, 10 comma 8, the two numbers that is left, right? So 7 to 5 will give us this one, 5 plus 2 7, 7 plus 7 14, and this gives us 18, 14 comma 18, right? 14 comma 18. So here the output that we got is 18, right? So among this max is 18. So here among this one maximum is 18. Yes, two subarrays are less than or equal to 21. Here yes, two subarrays are less than or equal to 21. So yes, it is possible. Now we will try smaller when high equals 21. When high equals 21, now we have got the mid equals 21. This itself we'll consider as high, because in the binary search we will shrink, right? We will shrink at each step. We will shrink at each step, means we will uh, half we will half the numbers basically, right? So when 7 to 5, this one, just consider this one, 1 2 3 something. Suppose if we have three numbers, accordingly with the binary search we'll be finding the middle number, and if we will be calculating either with the left or the right, left or right, right? So we will shrink into half every step in the binary search. We know this one, pure binary search, right? If you know the binary search, so we'll be going with a half every time. So this time we have got 21. This is just for the example sake, don't consider this one. So this one, now we got mid equals 21. Now we got mid equals 21, sorry, high equals 21. Last step mid was 21, now high is 21 and the low remains same, nothing but the 10. Low remains same, nothing but 10 here, right? So let me delete this one. I hope till step 1 it is completely clear. Now we have got the 18 here. We have got one subarray, so basically this itself will be the answer. We have to calculate for all the step, right? So we have to calculate for all the steps and see whether we have got the other, this one, what do we call, uh, other splits, where we can go with the other splits and we can get the large number, where we can get larger number than this one, right? So we need to check that one. So let me delete this one. So let's come to the second step here. We are done with the first step, so let's come to the second step here. Now this one, low still is 10 and high is 21. Now we have to calculate the mid. To calculate the mid, we will be going with 21 plus 10 by 2. 21 plus 10 by 2 is nothing but 31 by 2. 31 by 2. So this will be, so this mid will be here in this case 15. So mid will be 15 point something we'll get. We'll go with the whole number, nothing but 15 here, right? So this is fine. Mid is 15. So we have to split with the maximum that is less than or equal to 15. So now we can go with this one number, 7 is fine. 7 plus 2 is 9, and the 9 plus 5 is 14. So these three we can go with, right? 7 plus 2, this one, 9 plus 5, 7 7 plus 2, 9 plus 5, this one. So we can just go with 14 plus 10, the right side, the 14 plus 10, 14 plus 10, that is equivalent to 24. So here this will be too big, right? So it has to be 15, less than or equal to 15. It has to be less than or equal to 15. So we are going with the 24, which is wrong here. Which is wrong. Basically, no. Subarray 7 to 5 and 10 comma 8, we got the three subarrays here. One is 7 to 5, which will yield us to this one, 14, 10 and 8. 14, 10 and 8. These three we get finally. These three subarrays we get finally, but we have to split into only two. So this is not possible. K we have been given 2. So this is not possible again. So this is not possible. Increased allow sum is, now what we will do, this one, we will increment this one to 16. We will increment this one to 16, right? So now low becomes 16. Now from 10, we'll consider, let's come to the step 3 here. Now low instead of 10 becomes 16, and this one remains same. What do we call? Max remains same. High remains same. So the mid, to calculate mid, it will be 16 plus 21 by 2, nothing but 26, 36, 37 by 2. 37 by 2 is nothing but 18 we get, right? 36. Uh, so the 36, 18 point something we'll get. We'll go with the 18. We have to go with the 18 basically, right here. This one. 18, we tried splitting with the we have to try splitting with the maximum sum less than or equal to 18. So mid is 18 here, so that's why we have to try splitting with the maximum less than or equal to 18 here. In this case we got 7 plus 2, we can just go with the 7 plus 2 9, and 9 plus 5 14. These two things we can consider, because it has to be less than or equal to 18, one thing. So we can just go with this two splits, and this one 14 plus 10 again 24. 14 plus 10 again will lead us to the 24. So here we cannot split. So we can go with 7 to 5 and 10. 7 to 5 and 10, and then we can go with the 10 plus 8 18. So again we can go with the same thing that first we got the same thing, right? In the first step we got the same thing. The subarray 7 to 5 and 10 comma 8. Subarray 7 to 5 and the 10 comma 8. This two subarrays are okay. And again we will this time we'll try with the high 18. This time we'll try with the high 18. So let me delete this one. So again we got the same subarray 7 to 5 and 10 8. So we'll ignore this one. We already have got that split, right? So here in the first step itself we got 7 to 5 and 10 comma 8. So now what we'll do, accordingly with the binary search, we will consider this one. Low remains 16 itself, and high this time will consider 18. High this time will consider 18. We ignored 7 to 5 and 10 comma 8 because we already have got that one, right? 7 to 5. We are checking for the other splits where we get the sum more than 18, right? So we have already got this one 10 comma 8. So where 18 will be the answer, basically max among these subarrays, right? So here let's go with the step 4. Let's go with the step 4. Now it will be let me do one thing. Let's go with the step 4 here. So here 16 plus 18 mid will be this one. 16 plus 18 is nothing but here 28, 34. 34 by 2 will be 17. So we have to try with the max sum that is less than or equal to 7. So we can just go with the 7. 7 plus 2 9 here. 9 plus 5 14. And again 14 plus 10 will lead us to the 24. So here we cannot split. So we'll be going with this. Right. So one is 7 comma 2 comma 5 comma 10. Now 10 plus 8, same step, same thing, right? 10 plus 8 equals 18. No, again too big. We'll get too big because it has to be 17 this time, less than or equal to 17. 18 we cannot consider this time, right? So the mid that we got here is 17. So this 18 we got here, so this is not allowed. This is not allowed. This is not allowed. So what we will do here, we will increment this 17 to 18 at the for the lowest, actually. For the low, 18 will be there, and high is quite obviously 18. High remains 18 itself in the step 5. So here low is 18, high is 18. So we will stop the binary search. So both the numbers are same here. We saw every step, right? We saw every step. We saw every step clearly, right? So now low is also 18 and high is also 18. So as low and high are both equal, we will stop the binary search. We will stop the binary search. So the final answer that we got here is 18. So this itself we can return. The final answer that we got here is 18. This itself we can return, or we will return. Basically the output that we got here is 18. So same thing, exact same thing, you can just try it out for the this one second example. We have to get the output 9. I insist you to try out with the second example so that you understand the problem clearly, right? So I hope the solution, this one approach part is completely clear. We saw this one step by step. The same thing will be articulating in the form of code. The same thing will be articulating in the form of code. So I hope the approach part is completely clear. So yeah, we are done with the approach part. Same thing, whatever we discussed in the approach will be articulating in the form of code. So before hopping into writing the code, let's discuss the complexities quickly. So what will be the time complexity here? The time complexity would be big of logarithmic n. So why? Because we are making use of the binary search. We are going with the binary search. One thing here, so we are considering certain range, right? Particular range, nothing but max comma sum. So the maximum, this one number value that we got accordingly with the approach, and sum, and the sum nothing but the mid, right? So here these two things we have went with. So instead of this one big of logarithmic n, so the overall time complexity would be big O of n into log of sum minus max, sum minus max here, right? Sum minus max. So we reduced every part, and then finally what we got, the output 18, right? Finally we got the 18. So at every step we considered certain range, at every step we considered certain range, nothing but here we considered sum and the max. So we will be going with the so overall time complexity would be big of n into logarithmic of sum minus max. So this will be the overall time complexity, nothing but here binary search over range max comma sum, binary search over the range max comma sum. So overall time complexity would be this one, a second one that I have written, right? So don't get confused here. This is nothing but binary search over the range max comma sum, and big of n to check the, we have to check the valid splits, right? So in somewhere within the step we got three splits, basically three splits, which yield to the output 18 itself, I think. So we didn't consider that step, we didn't consider three splits because k we have been given 2 here. For the first problem, k we have been given 2, right? So here in this case binary search over the range max comma sum and big of n to check the valid split. So overall time complexity would be big of n into logarithmic sum minus max. So what would be the space complexity here? The space complexity would be big of 1, because we'll be considering only certain pointers, low, high, along with certain this one fixed pointers, right? So here in this case we are making use of the constant extra space, no extra arrays will be used, only will be making use of the counters, right? So overall space complexity would be big of 1. So the time complexity would be big of n into log of sum minus max, and the space complexity would be big of 1 for the code that we'll be writing in the future. I hope the complexities part is completely clear. I hope the complexities part is completely clear. Now as we are completely familiar with the complexities and the approach, we are good to write the code. Let's start writing the code. Let's start writing the code. Initially what shall we do? Let me assign load to 0 and high to this one, what do we call, 0. This is fine. So the next step here would be we have to initialize low as the max element and high as the total sum. So let's go with the for loop here. This one let's consider individual num of nums, which is given in the parameters, nothing but the nums array here. So at least one subarray must hold the max element, right? Either the first one or the second one, based on the k, based on the k at least one subarray must hold the max element. So let's go with low equals math dot max of this one, low comma sum. So this would be sorry, not the sum, num, right? Individual number, at least one subarray must hold the maximum element. So basically we have articulated the same thing in the form of code here. So at most one subarray, we have to consider at most one subarray as the whole array. All right, so for that one, how can we write this one in the form of code? High equals high plus num. So this is fine. So let's come out of this one, this for loop entirely. So let's do one thing. Let's perform binary search here. Let's perform binary search. As I've said, we'll be going with a binary search, right? So based on the binary search itself, we discussed the approach. So here, just give me a second here. So now let's perform the binary search. First step is while this one low less than high, while low less than high. First step is we have to calculate the mid within the while loop, right? So here I'll just go with, to prevent the overflow, let me make use of this one. Instead of low plus high by 2, let's go with, so low plus high minus low by 2. This is fine. Next step is we have to check whether we can split into two halves or not. We can split into two halves means I'm considering for the first example, it can be any number of halves based on the k that they have given. If they have given k3, we have to go with the three splits max, right? Three splits max, and three splits at any cost, and we have to find the maximum this one sum among the three splits, right? So here in this case, what shall I do? I'll be making use of the helper function, this one can split. I'll be making use of the helper function cas can split. So I'll just do one thing here. So I'll just go with private boolean here. Let me go with can split. This one will be in nums. So this will be int k and int max sum allowed. This is fine. So within this method, helper method, whatever we are writing, this one can split. We need a counter. We need a counter. So I'll just go with initialize the count to 1, and we need the current sum as well. So let me go with the variable current sum, and let me initialize this one to 0. Next step, let's go with the iteration part. Let's move on with the iteration part. Here we need the individual number of nums. So within the for loop, so simple if condition here, if current sum plus number. So we are writing this one based on the calculation that I showed within the approach. So if the current sum plus number is greater than the max sum that is allowed, right? So here this one, let me copy this one and let me paste it over here. So if it is greater than the max sum allowed, then let's start the new subarray. Nothing but let's increment the count here, and also let's reset the sum to current num. Let's reset the sum to current num. Here this will be, where is the current sum? This one current sum equals num. Let's assign the current sum to num, right? So we're just resetting the sum to the current num here. So else, if the current sum plus num is less than the max sum that is allowed, then we will be accumulating the sum. Nothing but here, let me go with current sum equals current sum plus this one num. We are just accumulating the sum here, right? So we are gathering the sum here. So this is fine. So let me come out of this one entirely. So the final step is, so we have to check whether we can split within the k subarrays or not. So I'll just return here count less than or equal to k. Count less than or equal to k, right? So this is it for the can split. This is it for the can split method. So here in this case, we are done with the helper method can split. So we have to use the can split method within the main function, right? So here let's continue with where we have left. Basically we calculated the mid, and then we have to check whether we can split or not, right? So here let's write the simple if condition. Let me go with can split. Of the parameters, I'll be making use of nums k along with the mid. Nums k along with the mid. So within this if condition, what we need to do, if it is possible to split into less than or equal to k subarrays with maximum equals mid, then we have to try smaller, right? So then we have to try smaller. This will be high equals mid. High equals mid. So else what we'll do, means otherwise we have to increase the allowed subarray sum. Otherwise we need to increase the allowed subarray sum, right? Accordingly with the approach. So here we have to go with, I mean we have to increase the left pointer. Means we have to go with low equals mid plus 1 for this one. Low equals mid plus 1. So here we'll do one thing. The final step is, we have to return low if low equals high. Means in the approach finally we got 18 equals 18, right? So we will be returning the low or the left, whatever variable name you have considered. Low high would be perfect for this. Usually we consider left and right pointers, right? For the binary search, 2 pointers and the sliding window. Here we have considered low and high, and low has to be equal to high. When low is equal to high, then we have found the answer and we will return the low, right? So here in this case, accordingly with the approach, right? So I'll just go with return low. So let me format the code once and let me hit the run button. Let me hit the run button. So I hope this works, man. No? So yeah, int num, this has to be num, line number 25. Individual num we are considering, not nums of nums array itself. So this has to work now. Let's see. So yeah, you can clearly see here the sample test cases are getting passed. So let me hit the submit button quickly. So here you can clearly see all the test cases are getting passed. Means the code works absolutely correct in this case, right? Um, I hope the solution part is completely clear. We just made use of the can split helper method so that to check whether we can split into the given k or not, and then we'll perform the steps accordingly with the approach that we discussed. And then finally when low equals high, means in our case for the first example 18 was equal to 18, right? Low was 18 and the high was 18, and in that case we'll return the low, right? So that's what we have done here. So I hope the solution part is completely clear along with the approach and complexities. For now this is it. Thanks for watching, guys.